Hello, good morning to everyone. Thank you for taking 2-3 minutes to watch this video. If you follow me, you know my job is essentially training and consulting in the plastics industry. And I've been giving a couple of seminars for more than 25 years now. And the BimsII, what I call BimsII, Understanding Mechanical Properties of Thermoplastics, is the upcoming seminar in early October at DTU in Denmark, Copenhagen. Easy to reach from everywhere. And it's a 2-day seminar we're going to have there as we do every year. Now, I just want to say a few words. What could be the benefit of that seminar and how did that started? My basic training was rheology, injection molding, processing at my corporate job at what used to be Solvay, now called ScienceCo. But in the last 15 years of my career, I was asked to also take care of structural property relationships and mechanical performance of plastics. It was new to me, so I had to start from scratch. Of course, rheology is a great foundation to start with, but mechanical and solid state behavior of polymers is a totally different topic. So I collected many books and started reading a lot. I found that it was very difficult to actually find a single book that clearly explains the foundations of why plastic parts fail and how they fail and all the aspects related to parts failures. And I just want to mention this book, which I cite in my seminar, from David Wright, who used to work for Rapra. Many other people have mentioned some of the numbers that you find in the first few pages of this book. And there's a couple of pictures showing the statistical observations of David Wright over his own career, where he was an expert called in court for litigations about plastic part failures. So he essentially has 5,000 failures that he observed, and he does show some statistical facts. For instance, about 1/4 of those failures came from stress cracking. And so further down in the book, he develops a full chapter on environmental stress cracking. And of course, among the more relevant reasons for plastic part failures, there are other phenomena or mechanisms. One would be creep, so long-term loading, which is a slow type of failure, impact, which is a fast loading and fast type of failure, fatigue, which is a cyclic loading, and plastics are pretty complex. And when you look at all these different aspects, as you know, timing is fundamental for plastics because polymers are viscoelastic, and that creates quite a bit of complexity and certainly a lot of misunderstanding. So I took inspiration from these statistical observations. Another relevant one is notch defects, of course. And so I developed the BimsII, this 2-day long course, to actually specifically look at each of these mechanisms of failure, trying to cover as much as possible. And as you know, we think we are good at predicting failure, for instance, with finite element, but most of what we do is a bit simplistic, a bit too much a copy-paste of what we know from metal. And plastics have their own specific behavior and response, mechanical response that explain the failure. So for instance, one of the most interesting observations is that virtually all the problematic failures tend to be brittle. And as you know, plastics can fail ductile or brittle. It turns out that ductile failure is quite predictable, and we're pretty good at predicting that. And ductile failure is what you typically observe in relatively short time failure under conditions of overloading, which we are able to predict by looking at, the yield strength of a polymer, for instance, and considering the von Mises equivalent stress. But when it comes to understanding, anticipating, and predicting correctly brittle failure, most of us would be totally at loss, and we really don't know how to predict brittle failure. It's more complex, and I spent quite a bit of time in that session explaining why and how brittle failure occurs, and how to make sure you take the maximum out of your finite element analysis if you are an expert in FEA, to make sure you don't miss on the prediction of brittle failure. So if you're interested, please join us October 2nd and 3rd at DTU. I'll put all the links for registrations in the comment. Thank you very much for taking a few minutes of your day, and hope to see you in October.